Well, hello friends, and welcome to the May 2024 SerenityOS update. We got quite a few things to go over this month, so let's get started. First thing on the docket is an improvement to chess. So if you've been following Serenity for a while, you might notice that this moves panel here is new. This is just a simple text widget that doesn't expand the board when you shrink it. And if I tell Chess Engine that I would like to play, when I make a move here, it gets recorded up here in the move panel, and eventually Chess Engine should make a reply. Let's see if I can not lose my pawn instantly. Great. So, this is just showing the typical PGN stuff going on. Wow, I do not know what to do here. But this was added by D. Gaston, so thank you very much for making our chess app look a little bit more like some other places you might play chess, like I believe chess.com has a display like that. Alright, something not so demoable, but this month Tim Flynn and I worked a bunch to improve our CI times. It was getting a little bit excessive sometimes with some of the jobs taking over an hour. So by the end of this month, we finally had all of our jobs moved from a mix of GitHub Actions and Azure DevOps to only GitHub Actions. And the reason we made this change is, first of all, GitHub Actions started allowing nested virtualization in all of their free tier runners, which is awesome for running things like QEMU in CI, which we do to run our test suite. Just absolutely, I think it cut our test time down from 13 minutes to 2 minutes, so that was incredible. I think we did that last month, perhaps. But now all of our CI jobs are using that pattern, and the other thing is that the Azure DevOps runners by default only give you like a 2-core Linux VM on some computer, but GitHub has decided that they're going to offer all the free tier runners as quad-core machines, for Linux at least. So now the CI runs significantly faster, and yeah, so really pleased about that. Hopefully now we can actually start narrowing down our flaky tests now that we don't have to wait an hour sometimes to figure out that our tests are flaky. Okay. Next thing, probably the most important change this month, is one to CatDog. So if we look at our CatDog here, this was a change made by the only ASDK, and now we can put our CatDog to sleep and manually wake him up. If he is already asleep. So this does appear to be a bit glitchy. So I think there might be some states and modes shenanigans that we could do, like this isn't animating, but still very important feature to keep improving CatDog over time. We need to make sure that he gets all the sleep that he needs. Okay. Goodbye, CatDog. Next undemoable change here is that so we're using Clang 18 and GCC 13 for our cross compilers to actually build Serenity. And this month I made the change that now we are compiling with the C++23 flag when available instead of C++20. This didn't change anything because we aren't using any C++23 features, but now we can. And as a result of this, I think the most interesting feature probably is deducing this, is the one I'm most interested in. But that's only implemented starting in Clang 17 and GCC 13, so we have as a result of bumping up to C++23, bumped our host compiler requirements as well. So if you want to build Serenity or Ladybird or any of the Lagom apps, you're going to need Clang 17 or GCC 13 from now on. Okay, next up is the dynamic loader. So this is the application that runs, this is the executable that runs to launch your application when you start it. So if I run ls, the elf interpreter for bin.ls should be, yes, gosh, why does this look so terrible? Wide, no? Guess my terminal's too small. Anyway, the ELF interpreter for all of our applications is this bin loader program, or user lib loader. I don't know why I keep saying bin. But, yeah. Compiler, or the kernel, loads this application, tells it that you're supposed to be bin.ls, and it goes and it finds all the shared libraries that bin.ls needs, loads those, and then jumps to main. So this is our pre-main implementation, similar to ld.so on a GNU system. So Leov added a couple of features to this this month. So I believe we can do -d, and it will not do anything. Maybe I don't understand what -d does for dry run. Okay, I don't understand what that does. But I do understand what the list command does. So this will... I'm not sure what that one's about. But this is similar to the LDD program on Linux. It just lists out the dynamic loader dependencies, the dynamic library dependencies. So the Windows server needs all these libraries, and the browser... Whew, why did it end up running then? The browser needs all those dependencies. Good lord, that's a lot of dependencies, isn't it? So, yeah, thanks to Leov for implementing that. Some other changes to the dynamic loader this month is that Dan Shaders did a bunch of build cleanup for the dynamic loader. It's now built in a less kludgy way. It kind of was very organic, so he went in and cleaned up some of the mess that we had in there. And he improved our weak symbol support, so hopefully if we start porting more applications that make heavy use of weak symbols, we won't trip over them as much as we used to in the past. Okay, next couple things that aren't quite so demoable is we have some kernel changes that are in the pipe that I haven't quite reviewed yet, and neither have the other maintainers, so sorry everyone that has pending kernel patches, but there are some interesting ones coming down the pipe for booting. There's some chatter in the kernel channels about working on UEFI. I know Leov has a big PCI refactor that he's excited about. There's some USB patches. So hopefully we can actually get to those when Ladybird calms down a little bit, which should be soon. All right, so Kirill implemented a VirtIO block device driver. I don't really know how to demo this, but if you go look in the commit and in the run.sh script, there's now an option to attach the root file system as a VirtIO block device instead of a NVMe device, or actually I think we removed ECPI boot, but or ATA drives. Anyway, we now have more options for attaching the root file system, more VirtIO support, which is always exciting because VirtIO is probably the best way forward for us to port to multiple different architectures. Attaching VirtIO devices to QEMU is pretty simple, and supporting real hardware is hard. All right, next one is a quite interesting feature from Implicit Field, and that is Fuse file system support. So this is the user file system. I believe it's based on the Fuse 3 library, but it's our own homegrown implementation, of course. So here I have installed the libfuse port because we don't quite have the utilities to exercise this kernel feature on our own in the repo yet, though I know Implicit Field posted like a service daemon in the pull request. But right, so let's, without any further ado, let's run local bin ditto. So I created a folder called fs here. It's completely empty. So if I run this hello application from the libfuse port that we have now as root, we have now mounted a Fuse file system there. So if I check df, yes, if I check df, we can see that we've got all of our ext2 file systems mounted in the usual places. with their flags and whatever else. And in home anon-fs, we have our fuse file system. And what else? Does it show anything up in mounts? Yes, it is read-write. Cool. Well, I think df is actually more interesting than mount. Anyway, if I go into that directory and list, we have hello, which is a file that has the text hello world. I could have passed some options to that hello demo app, and it would have changed the name and whatever. Note that we don't actually have... Be right here. I cannot actually make directories, and I cannot make files because those aren't implemented in the libfuse file system driver. But even just the ability to create... actually, maybe that's just the pro... I'm not sure why we don't have this feature, but I'm excited to give at least a semi-educated demo of this fuse file system support, implicit field added, and hopefully we can build on this in the future, because I know that I think Leo was talking about some options we could use fuse for in the future. But pretty cool file system from the Linux and BSD world, and we can now use. All right. Next thing that's not very demoable is RISC-V 64 support. I believe either the last month or the month before I demoed that we can actually boot that. I believe we can get further, but I didn't actually test it. I'm expecting that by the demo video next month we should be able to show a fully working we might be able to show a fully booting and mouse working and keyboard working, maybe network working RISC-V 64 QEMU. I know that Sonke has been working pretty hard on that, and working with some other folks in the Discord, get that working, and working with his Sci-Fi Vision Pro 2 board that he has. Also, on the RISC-V front, Leon added a bunch of support for more device tree bindings, and actually using the device tree to bring up RISC-V. Hopefully we can also port our Raspberry Pi ARM64 port to use a device tree, and then we won't be so tied to that hardware. So some pretty interesting things coming down the pipe for booting. Okay, next thing here is the ping utility, which, you know, it's ping. You can ping, send ICMP messages to servers and check if they're alive. But now we have two new options to this added by Marios. These are adaptive ping and flood ping, and I believe these are documented. No? I thought I saw a commit that documented these. Huh. Why is that? Why is that different from... Okay, so it's in the help page, but not in the man page. Maybe we should take a look at that. Or maybe I missed something. But anyway, adaptive ping adjusts the interval to the round trip time, and flood ping just spams the crap out of the remote user. It's quite rude to do this on a public host, so only super user can do that. But I can probably use the adaptive ping here to 8.8 is Google. Woo! Okay, maybe we don't want to do that. But it does adjust the ping time to the TTL, which is neat. All right. So, thanks to Marios for making ping better. All right. Last utility here to demo is Shred, which I believe is... It's at least a core util utility. I'm not sure if it's POSIX or not. But what this is meant for is very thoroughly destroying files. So if I create a file, I don't know, edit, oh, text editor. Hello. I add some content to this file, very important data. Then I can use the shred utility to very much delete the file by overwriting it with random bytes before. Actually, I'm not sure if it deletes it. Let's find out. Yeah. It overwrites it with random bytes. Okay, it doesn't delete it. But this is meant for letting you do more thorough destruction of your files. Because, if you just say delete the file, we delete the inode, and the data stays intact on disk. So if someone who you don't like comes in with data recovery tools, they can recover your data if you haven't scrambled it up with a tool like this. So this is a common Unix utility that I had never heard of before I saw this PR, but it's nice to have more utils. All right. One last thing before I sign off here is that we've had a whole lot of Clang tooling updates by Matco this month. So I don't remember if Andreas mentioned this in his recent videos, but for a while there we had a tool called, or we had some standalone Clang tools using libclang that would verify certain properties of our code, and Matco has taken the approach of transforming these into Clang plugins. So now, if you set the right CMake flag, we will build these. This isn't the right CMake list, but we'll build these plugins and we'll pass them to Clang when we build our code. And so the first one of these tools is this Lambda capture plugin. Basically, here we have this variable. He also wrote some tests using lit, which I'm very pleased about, because we could possibly upstream these if people find them useful. But here we have some random variable, and we have a function that does not have any annotations, and we take this by reference and we call it, and everything's fine. This is still a bit awkward because we're taking a reference to a stack variable. But this other function here is marked with escaping, and I believe that is, yes, the Serenity escaping annotation that we have manually declared. And when this argument is annotated with this escaping attribute, now we get a warning that this function has said that it will take, this method has claimed that this argument is going to be stored and then executed later. And we have this pattern a lot where we pass a function to the event loop as like a deferred invoke callback. We pass a function to promise in libweb to say, here's a JavaScript object, call this C++ function when it wants to do something. And we do this for tasks. So when you want to queue a task on the web event loop, this comes up a lot, where we have a function that outlives the call that it was a parameter of. I'm not sure if I explained that well enough, but this is unsafe for a function that escapes the current context, because we'll be referencing a random point on the stack and we'll get weird crashes later. So we have a plugin that will give us warnings, or actually errors, if you enable it. I believe the plan is to make this work in CI, but there were some troubles with getting all the right packages and ducks in a row and whatever else. In addition to this escaping annotation, there's this really loud and obnoxious ignore use and escaping lambda annotation that we can mark this variable as fine to take by reference in a escaping lambda or function object. Okay. The other bit of this is the JS verifier, and there's quite a few features that this has, but what's the best way to show this? So we have one to make sure that when you have, so here's a typical use of libjs. You have some object that you want to you have some class that you want to derive from JS object. So you have to use this macro to set up some boilerplate. And if you have any data members that are themselves GC allocated, you must have a visit edges function that takes the cell visitor and visits those as part of our mark sweep GC. And the first thing in that visit edges has to be this call to base visit edges. So this one of the passes that this plugin has is to make sure that you follow all those rules. And there's, yeah, so this one will, well, this is a fix me that maybe we should complain that you didn't actually visit this object. But yeah, we have all these tests to make sure that you follow all the rules of libjs. Like this one doesn't call base visit edges. This one has a bunch of JS cells or GC allocated objects that aren't wrapped in GC pointer. This one, you forgot to visit your base because even though you don't actually have any reason to override this function, you have to call base visit edges. Yeah, this one you didn't visit it, so this is a raw GC pointer. Okay, anyway, we have all these test cases, and they're all amazing. I believe, yeah, Andreas had a bunch of issues open with some ideas for types of things we could check with a plugin that we couldn't really check with code review or other pre-existing static analysis. So the fact that we now have the ability to write our own static analysis for the rules that we have defined in our own code base is pretty exciting. So with that mostly explained, I believe that's all I have for you. So I believe that Lucas has something to say about libgraphics, and after that I will see you guys next month. Bye.
Well, hello friends, I'm Lucas, and today I'm going to show you the libgfx improvements. So this month we have seen the introduction of two new image encoder. First one is WebP, written by Nico, and second one is GIF, that I wrote myself. And yeah, let me demonstrate that to you. So first I'm going to show you this example. So this is a animated GIF that we found online, so like a very common example. And I'm going to transcode that to WebP first and then to GIF. Yeah, so to do so we are using the animation utility. So this is something we also add this month. And yeah, it allows you to like re-encode or transcode from one format to another. It's basically the same thing as image that we already have, but it's specialized for animated image. So yeah, let's do that. So cat.webp, and now we can open it. And yeah, it's, as you can see, basically the same image, so that's what you would expect, and everything is working correctly. And now I'm going to re-encode the GIF with our own encoder. And here you go. So yeah, we are going to have these three little cats to stay with us. Yeah, there is one thing that I want to show you. It's the size of the file. So as you can see, the original GIF, it's 11K. The re-encoded GIF, it's 13K. And the WebP is 120K. So yeah, it's pretty much a big difference. And that's something that we are going to work on. So yeah, I guess you can check out that next month. And then there is also this image that I want to show you. So it's a basic PNG file and nothing new on this side. The thing that is new is that we are now able to load the EXIF chunk. So we can now read the metadata from PNG file, and that's pretty cool. And that's it for the libgfx change.